In this video, we discuss methods that could be used or couldn't be used to prove that the language L is context-free. So, could we use the pumping lemma for context-free languages? Remember what this lemma tells us is that pumpable implies, not pumpable implies not context-free, and equivalently, context-free implies pumpable. Okay, so here we don't have that pumpable implies context-free. Okay, this is not true. We don't get that from the lemma. Okay, it might be the case that something is pumpable and not context-free. The only thing we can use the pumping lemma for is to prove that something is not pumpable and therefore cannot be context-free. Okay, so we can't use this to prove that something is context-free. Okay, how about designing a Turing machine that recognizes the language L? So let's remember that if this is our Turing recognizable languages, our context-free languages are a proper subset of the Turing recognizable languages. So if something is context-free, it is Turing recognizable, but if we know that a language is Turing recognizable, we can't conclude that it's context-free. It could be here. Okay, so just showing a recognizer doesn't tell us that the language is also context-free. So this doesn't work. Okay, how about using the pumping lemma for regular languages? This is the same argument as using the pumping lemma for context-free languages. Okay, so this tells us regular implies pumpable and not pumpable using pumping for regular languages. Not pumpable implies not regular. But notice that we don't have that not regular implies context-free. Okay, this is not true. Let's think about our picture. We have regular, every regular language is also a context-free language. But then we have other languages out here as well. Okay, so we have some, let's just make these the decidable languages. Okay, so showing that something is not regular might give us it's out here. Okay, this would be non-regular, but it's also not context-free. So this doesn't work. How about designing a context-free grammar for L? This one does work. We have that a language is context-free. Free. That doesn't look like free. It's context-free if and only if there is a context-free grammar that generates the language. Okay, so this is a bidirectional implication. So if a language is context-free, then we know there must be some context-free grammar that generates it. Likewise, we know if there is a context-free grammar for a language, that language must be context-free.